In this video, we are going to look at a couple of examples how we can talk to Hover Group devices using NodeRed. This video is not going to be a beginner's guide how to use NodeRed, so I assume that when you are watching this video, you have a basic understanding what NodeRed is and how to use NodeRed. Of course, the flow that I'm showing here is going to be available for you to download and play around with. In this video, I'm going to go through a couple of scenarios, how I can connect to the ST2, which is on my local network, and also how I can talk to the same device if I have them connected to the SensDesk portal. So in this example, I'm going to use the ST2 and also the narrowband device to get data for both of them using SensDesk. And with the narrowband device, because it is using mobile network to communicate over the internet, the only option I have is to use the SensDesk in order to talk to it. But if we are using NodeRed, we shouldn't have any issues talking to these devices, either the ones that are on the local network or the ones that are on the open internet, and just use SensDesk to communicate with them. I'm going to go through a couple of scenarios to show you how you can get data and how you can build basic visualization and what you can do with the data. As you can see, I can already visualize information which is coming from the ST2. So I have the temperature probe here, so that shows me the temperature data, and it also shows me the temperature in the graph. And I have the various inputs that I have switches connected to it, or push buttons. So if I push this one, which is connected to input 1, we will see that the input 1 state changes. I also have some additional functionality where it counts how many times we received an input from that digital input and how long the input was on. And I also have the other switch, which is connected to the normally closed connection. So this is why it shows closed in the, let's say, in the normal state. But if I press this micro switch, then the status of the digital input 2 changes to open. So in both cases, we see the changes in the physical inputs reflected in the dashboard. And I've also added some additional functionality. So for example, we can calculate the minimum and the maximum temperature in the last 24 hours. We can also specify states. So this is similar how you can specify safe zones. You can basically define them in NodeRed as well. So this should be able to give us a status whether the temperature is now above freezing or below freezing. And if we are pulling data from the SensDesk portal, then we have the option to pull data from multiple devices. In fact, all the devices that we have configured in the SensDesk. And this is what I wanted to demonstrate in the second graph, which shows the temperature data from the ST2, but it also shows the temperature data on the narrowband device. So I can visualize multiple data series in a single chart. In order for us to understand how we can get data from devices locally, for example, this ST2, which is beside me, I have to navigate to the device site on my local network. And if I come to the last page, which is the system, we can see that we have two XML files. There is a values.xml and the setup.xml. And if you look at the URL, this has a fixed URL. In fact, it's the device IP/values.xml or setup.xml. And this is actually what I'm using in NodeRed in order to get the data from the device. So I can create an HTTP request node, such as this one. I put the URL for the XML, and then I format the output from an XML to an object. And if I just run this very simple script, we can see that the entire object is now available in NodeRed. And this is a fairly complicated structure. As you can see, I have the agents or the devices that are listed here. So this is the STE device. And if I go to the sensor set, I can also drill down and then look at each of the sensors. So the ST2 has two inputs, and on one of the input there is a float sensor configured. So let me go back to the the home. So if I go back to the ST2 homepage, I can see the float sensor and the temperature sensor and the two inputs. And these are the values that we can also see here in the output of the XML. So if I drill down the second sensor, that's the temperature sensor. And if I drill down the value, I can see that it is showing 23 degrees at the moment, which we can also see here in the dashboard. So it shows you how easy it is to read the data and also just use the simple debug functionality within NodeRed to understand what is being supplied by the device. And similarly, I can create a second HTTP request node, which is going to read the setup XML. And I also convert it to an object, and I can store some of the information that I want to use later in the flow. So for example, when we are talking about this device, I have configured the various status of the digital inputs. So whether it's called open or closed, and also what the name of the sensor. So in this case, the sensor 61834. And I can just store them in NodeRed, so I can use these values. And as you can see, I'm just storing them in flow variables. And when you look at either the values.xml or the setup.xml, and NodeRed actually gives you a lot of helps. So for example, if you want to get this value, you want to refer to this exact value in the XML, you can click on this icon to copy the path, and you should be able to use the path, for example, edit here. So I want this variable from the message object, and you just have to paste, and then the exact path for this variable is going to be shown here. The next set of functions that I implemented here, it basically gets the current state from the values XML from the ST2, and it does it every second. So as you can see, the HTTP request is getting triggered every single second. And then I'm use this data to show these blocks here on the dashboard. So I can check the state of the input 1. So this is the path to the input 1. I check whether the value is 0 or 1. And then depending on whether it is 0 and 1, I replace it with the value from the setup.xml. So this is why in the NodeRed dashboard, whenever I push this button, the open changes to closed and vice versa. And this is basically the statuses that I've configured here. So you can see the two open and state closes. And if I would rename these and I trigger again to download the setup.xml, then those different statuses would show up in the dashboard as well. And I can do the same for the input 2, what you can see here. And I've also created this function node which calculates the on time. And this is a piece of JavaScript code which listens to the various inputs that are coming in, and then stores information and calculates the on time. And besides calculating the on time, it is also calculating how many times the input 1 has been pushed. So now you can see that it is giving us a feedback that the input is now actually on. I pushed this input 5 times since the flow has been reset, and now it's been pushed for, let's say, 13 seconds. So you can just easily measure, let's say if it's connected to a door sensor, how long the door was open. And this information which comes out from this function node is actually shown here in the dashboard as well. So it updates these two fields, the counter and the on time. I also want to show you a couple of examples how you can use NodeRed to send messages to other services. And I'm going to use email and Telegram in this example. So here you can see that besides showing all this information in the dashboard, I'm also extracting the value of the input 1 push button. I'm using this RB node to only show me the changes whenever it changes from 0 to 1 or 1 to 0. And if the value is 1, then I'm generating a Telegram message. And in the Telegram message, I just specify what is the text, and it's a message type, so a text message type. And I specify a chat ID, which is my unique ID that I use in Telegram. And for the testing purposes, I created a new chatbot in Telegram. And you can see that whenever I press the digital input 1, I also get a message on my phone that the first one gets triggered. And I'm also getting some other graphs as well, which I'm going to talk about just in a couple of seconds. And of course, Telegram is just one example, which is integrated in NodeRed. There is a lot more other messaging services that you can use, or you can also use email and Twitter to send messages to yourself or anyone who needs to be notified if something happens on any of those devices. The next example is related to the graph that I'm showing here. And in this case, I'm reading the values.xml from the ST2 again. I could have received the data from here. I just wanted to keep this flow separate. But here, this is getting triggered every single minute because what I'm interested in here is more about the temperature, and the temperature doesn't change that often that I need to read it every single second. So getting the values.xml, I'm converting it to an object so I can use it to generate the chart. So first of all, I just extract the information that I need. So I get the name of the sensor and the value of the sensor 1, which is the temperature sensor connected to the STE. And I show it in various UI dashboard elements. So I show it on a chart, which is a gauge type, and I also show it in a simple graph. And using the graph is really easy in NodeRed because you can specify the basic behavior of the chart here. So this is going to be a line chart, and it's going to show you 2 days worth of data. So all you need to do is send in data, and it will automatically just update the chart every single time, and then just push the data out, which is older than 2 days in this case. So this chart is getting generated by that node, and this temperature gauge is getting generated by the other node that I just seen. And using some very simple nodes, I can also instruct NodeRed to remember the minimum value from the last 1440 values, which is the number of minutes in a day. So this is why it's going to show me the lowest reading for the last 24 hours. And pretty much I can do the same for the highest value. So it's going to show me or return the maximum value for the last 1440 readings. And that just basically just goes into the dashboard again. So this is why we see these 2 values here showing up on the dashboard. Besides storing the data in the dashboard, I've also created a function node which does what the dashboard chart does internally automatically, which is storing the data for the last 2 days. But I have done the similar functionality here using a piece of JavaScript code, which is storing the last 1440 readings. So that again is going to store the temperature for the last 24 hours. Because what I wanted to do is, besides storing all these data, I also wanted to create a chart for myself that I send in Telegram. So here I'm always going to have the readings for the last 24 hours. And then every 6 o'clock, I think I specified here. So every 6 o'clock, I just send the flush command, which sends out all the stored readings. And from those stored readings, I generate a chart. So here I'm again using a piece of JavaScript code to specify what type of chart I want. So here I'm not using the dashboard element because I don't want to display this chart on the screen, but I want to generate an image of that chart and send it off in Telegram. And I have a node which converts this chart to an image. I save that image and I construct another Telegram message which contains a photo. It specifies the link to the file that I just saved, and it also adds some text. And this is what we have seen in the Telegram just a couple of minutes ago. So as you can see, every 6 o'clock in the morning, I get a chart with the readings for the last 24 hours. And for the sake of simplicity, I just used a single data series here, but I could have used multiple data series, so I would get multiple readings in the same chart. And as you can see, I'm getting these every single day. But since I have the chart generated as well, I can not only send this chart in a Telegram, I can also create an email message. So here I'm setting up an email message, which is going to contain the image of the chart as an attachment, and I'm just sending it off to a email node where I've configured my Gmail account. So I can see here that every single morning at 6 o'clock, I'm also receiving that email, and that email has the exact same chart that I received in Telegram. And what I have done further up in the flow is I'm checking the value from the temperature every time I receive a temperature, so every minute. And depending on whether the temperature is below 0 or above 0 or actually above 25 degrees, I do various things. So this is where I configure whether the actual state for the temperature reading is, let's say, below freezing or above freezing, and that's get printed on the screen here. But depending on these temperature values as well, I can also send Telegram messages. So for example, if the temperature value exceeds 27 degrees, I can again just generate another Telegram message, which is simple. It just simply says there is a hot temperature alert. but I can also generate myself a simple email. As you can see, I specify what the email text and what the email subject should be. And I also send this information to the same Gmail node that we have seen earlier. And if I open my Telegram client, I scroll the way down, now we can see that I've received the hot temperature alert. And this is the email message that I received. Again, the subject and the body of the email that we configured in NodeRed. And now we arrive to the part of the flow where it starts using the SensDesk portal to read the data from the devices instead of using the direct XMLs. And if I navigate to my SensDesk, and within that you just click on your user ID and you click on My Team, then you find this tab which says values.xml. And here I'm going to use the team URL, which is going to give me the data for all the devices. And please also note the instruction here. When you are using the SensDesk portal, obviously you have to restrict how quickly you are reading your devices. So what I've configured here for the SensDesk is that it's reading the sensor information every 15 minutes. And if I just trigger it now manually, we can see the object or the information which is retrieved by the SensDesk portal. It is going to look fairly similar to the individual XML, but it's also going to have some differences. Mostly that we have an additional node which is called the devices, because, well, obviously now we are receiving information from multiple devices. So all the devices that are under your account are going to show up here. So as you can see, I have 4 devices, and if I start drilling them down, I can see each of them here. So if I drill down to the names, so this is the SD, and then the second one, that's the narrowband device. So these are the names that I'm getting here. And if I drill further down, I would probably see the ST2 and also the RS12, which is linked to my account. But under the devices, I still have access to all the inputs or the sensors that the devices have. So I can get pretty much the same amount of data what I would be able to get if I talk to the device locally. I wanted to give you slightly different examples using the SensDesk XML than the local XML. I mean, I could have implemented the same functionality as well, but I was trying to do something new and additional. And first of all, I wanted to show you how you can show multiple data series in a single graph, which is actually fairly easy with NodeRed, because NodeRed chart is really for giving how you send information. The only thing it really cares if the topic of the message is the same, it treats that message to belong to the same data series. So all I need to make sure is that I send the messages with a topic which is either the narrowband temperature, which obviously the value which is coming from the XML. And here I just had to do some mathematical operations because the value that I'm getting from the narrowband device is the raw value. So I just had to divide it by 1000 to get the actual temperature reading. And for the second value, I set the topic to ST temperature. And again, I'm just extracting the data from the XML, which corresponds to, as you can see, that's device 3 is the ST device. And then sensor 2 is going to be the temperature sensor, because the first sensor was the float sensor. And here I had to divide the value by 10. And by setting these topics, we can see that the chart automatically splits or generates the 2 data series and shows the 2 charts. And when I hover over the chart, I can also see the name of the data series in the legend. And since I'm getting all these readings, I thought I'm going to show you how you can store them locally. And this flow that you can see here, which is called the autologger, is going to save the values in a CSV file, and then it's going to start a new CSV file every single day. So you can see here that I'm preparing the input information here. So I'm adding a timestamp with the current timestamp, and I have 2 data series, the NB and the ST2, or data points. And again, here I'm just preparing the values. I'm getting the values from the XML object, and I'm also doing the divisions that I've just mentioned previously. And I created another function node, which looks a little bit complicated, but all it really does, it always generates a file name from the current timestamp and using a prefix text. So it's going to be have a group underscore and the year, the month, and the date.csv. And you can see this one here. And then the system checks whether that CSV already exists. And if the CSV exists, then it's just going to append a new line to the CSV. If the CSV doesn't exist, then it's going to create a header, so it's going to have column text, and also it creates the reading, and it saves the file in the local storage. I created this dashboard, which is called a file browser, which looks like a Windows file browser. And I know that I'm saving these files in the data log folder, so I basically just change the data log folder, and you can see the HWG files created here for every single day. And I can also click on any of these files which gets downloaded, and if I click on it, it's going to show me the CSV file in Excel, and you can see the readings here. So the timestamp is just the JavaScript timestamp value, but you can see the narrowband and the ST2 temperatures logged here in the file. And because it's getting executed every 15 minutes, then we have, you know, this many readings for a single day. And you can also use NodeRed and the dashboard chart to pass in a whole series of data. So not just piecemealing data every time it comes in. So I can, for example, select any of the files that I've created or generated based on the readings and pass these values straight into the graph and show both of the temperature readings for that day.